Okay, so today we're going to be going over more of the basic motor movement, and we're going to be covering a little bit more loops, while loops. So today we're going to be going over how to do the Sentry Simulation 1 challenge. So let's go ahead. I started a new program. I've named it Sentry Mission, right? And let's do the motor and sensor setup. And let's set it with the square bot. So apply, okay. And we're given this pragma configuration, right? And that all that means is it's going to be a preset for all these motor names and where they are and the ports, as well as analog and digital sensors. So now that we have that, we can go ahead and start. Actually, before starting, what we should always do is we should see what's going on, like what challenge are we trying to find, what challenge are we trying to complete. So go to remote movement, and Sentry Simulation, and we see this activity, and the goal of this activity is to basically make take a complete trip around this square. Alright, so we're gonna have to go a specific distance, turn, go a specific distance. So, and since we're doing something in a repeating nature, what we can use is the loop, and we'll see how that comes into play, right? So obviously, what we do first right here is we'd say, let's go ahead and just say motor, left, motor is equal to 127, right, motor. And important thing here is to make sure the naming is correct. You can see what the motors are named in the configuration as well, right? So it tells you right here that it's right motor with a capital M and lowercase r, as well as left motor, lowercase l, capital M. So we see that, and let's just say we run it for, say, 4 seconds. Hopefully that fits into the requirement. So right here, Sentry Simulation, start activity. Let me switch the camera too so we get like an over eagle eye view. Okay, so I think it just managed to stay on the table, which is not what we want. We want it to be able to stay in this white path. So let me just minimize that, and instead of 4 seconds, let's say 3 seconds. See how that looks. And it's important to remember that whenever programming, an important part is being able to stick with the problem and persevere, right? So let's go ahead, try 3 seconds. Three. Okay. 3 seconds is also a little, might be too less, right? So let's just try 3.3. Let's just see how that works out. Download it to the robot. Okay. Yep, seems to be perfect, right? Right where we want it to be. So now what we want to do is we want to be able to turn our robot close to 90 degrees, right? And just be able to continue in the same pattern and go for 3.3 seconds forward. So the way we're going to try to do that is, let's go ahead and try to do a point turn so that we stay in the same position. So we'll say motor, right, motor is equal to negative 127. Right? Yeah. We're going to want the right motor to go backwards and the left motor to go forwards. So motor, left, motor, and 127. And it's important to remember the format when doing this. Always have the semicolons at the end. And motor is a method, so we're going to need to keep these brackets right here. And let me just try that for 1 second, right? So wait 1 second. See how that works. Okay, 1 second might be too much. So let me go ahead and make it 0.6. Might work out better. Yep, very close. Let's try 6.3. Right, again, we're gonna have to persevere with this problem. I like it to be a little bit like close to perfect, right? And plus we don't want our robot to, all the small like inconsistencies to add up and for our robot to mess up. So let's try to get this as close to possible as 90 degrees. Yep, I think it's near perfect. I'll just say 6.4. Right. Okay. Yep, I think it's good enough. Yep. So now what we can do is, we know copy and paste is our friend, so we can just continue to copy and paste this. So this is one going forward, turn. It's gonna go forward, and it's gonna turn, and then we need it to go forward once more, and turn once more, and then it's gonna have to go forward again and turn. So I think hopefully I counted correctly. So let's go forward, turn, go forward, turn, go forward, turn, go forward, turn. So 4, right? So it should work out. Okay. Let me see what happened. Saying it's a little off, right? Yep, and that's what I was talking about with all these small inconsistencies in our turn. Obviously it made the first turn. You can see as it's more and more like a cant, more and more at turn, it's gonna end up hitting. So let's go ahead and try to fix this a little bit more. Just go ahead and delete all of this, and we just want to make sure one turn is working before we actually, I think we'll, no, okay, so we can keep it like this. And right now we're seeing what the issue is. The issue is that we're turning too much, right? So let's just say 3.5. Yep. Okay. Looks perfect. Well, that's what we said about the last one. So let's just not hold our breath or anything. But okay. So it looks good. Now let's just copy and paste this 4 times. Let's see. I'm pressing Control C. Okay. Just the camera too. It's cutting a little close there. Okay, but yep, it worked, right? And although it worked, we're always going to be trying to optimize, and I'm sure it was pretty apparent when it happened, but obviously copy and pasting or sometimes typing it all up becomes very tedious, and that's where loops come in to help. So let me go ahead and delete the rest of this. So in our case, we're going to go ahead and use a while loop, and all a while loop does is basically says we're going to run this code while a certain statement holds true. So in our case, we're going to want to make an infinite while loop, so we're going to have to come up with a statement, obviously, that's going to hold true forever. So let's say while, and there are multiple ways to do this, but the way that I like to do it is just saying true, while true, and we have these brackets right here. And all this must be held inside the while loop. And I'm going to go ahead and make this 3, right, because we saw even then it was cutting a little close. So let me just compile. Fixed formatting, right? So fixed formatting just makes sure that it's set all in like a nice, easily readable way. So let me compile again and download to robot, and hopefully we're done with this, right? A little odd. Yeah, sometimes I think there's just like a little hiccup in the software. Right? Yep, that looks a lot better. Yep, and we've completed it, right? So using the while loop, we're able to optimize our code, and that's it for today. So you can see that we covered a little bit more of the basic movements and the while loop, right? And we were able to complete the Sentry simulation. Okay, that's all for today.